In this video, we're going to discuss how to find the points of intersection of two polar graphs. If you have not yet watched video 3, you're going to want to see that first so that you can recognize the types of graphs that we're dealing with before we start on this. Okay, so we're going to look at number 9 that was on your polar graphing worksheet, and be sure you read the instructions. I am not going to make the table. I am going to sketch a graph, but the instructions asked you to find the point of intersection for these two graphs and then to graph them and make a table. Okay, so what we need to do to find the point of intersection, we want to know where these two graphs cross or where they're equal. So if r is equal to 3 sine theta and to 2 minus sine theta, then those two quantities have to be equal to each other. If they both equal r, those are going to have to be the same. So what we're going to do is we're going to set them equal to each other. 3 sine theta equals 2 minus sine theta. Now we have to solve this equation for theta. So that we've got a trig equation. I want all the signs on one side, and I'm going to leave the 2 on the right side where it is. So if I add sine and move this to the other side, I'm going to end up with 4 sine theta equals 2. I divide both sides by 4, and we get sine of theta equals 1/2. So now we have to figure out where does sine equal a half. And think about your quadrants. Since 1/2 is positive, sine is positive in quadrant 1 and quadrant 2. So I'm going to need an answer in quadrant 1 and quadrant 2. And then I'm going to use the hand trick to get my reference angle. So remember, sine is y over r. And on the hand, we know r is always 2. But to get our y to be 1, we're going to have to use the ring finger so that we have y as square root of 1. Okay, and that finger represents pi over 6. So our denominator is 6. So quadrant 1, we're going to have pi over 6. In quadrant 2, remember it's denominator minus 1. So 5 pi over 6. So those would be the angles, the theta values, where our graphs are equal. Now, once points of intersection, so we also have to figure out what r is. So I'm going to come back up here to either equation. Let's take r equals 3 sine theta, and I'm going to plug in one of my theta values. So 3 times the sine of pi over 6. Well, the sine of pi over 6 was 1/2. So 3 times a half would be 3 over 2, or 1/2. So our points of intersection, and remember polar coordinates, it's always r comma theta, would be 3/2 comma pi over 6 and 3/2 5 pi over 6. Now remember 5 pi over 6 and pi over 6 had the same sign value, that's why I didn't plug both of them in. But those are your points of intersection. Okay, so if we look at the graph, remember 3 sine theta, any graph that's in this form is going to be a circle. Okay, the number in front gives me the diameter. And since it's sine, it's going to be along the y-axis, so I'm going to have a point at the pole. I'm going to go up 3, and then I'm going to sketch in a circle, and these aren't going to be perfect. Okay. Okay, now I just said that my points of intersection were 3/2 pi over 6, so I can go ahead and graph that point. Okay, and 3/2 5 pi over 6. Okay, so that gives me 4 points on that circle to make sure I get them accurate. Okay, in the other graph, the 2 minus sine theta, okay, if you remember, if it's added or subtracted, it's going to be some kind of limacone. Okay, and if you look at your values, your A and your B, A is 2, B is 1, so the ratio comes out to be 2. Okay, and if it's greater than or equal to 2, then it is convex, which means it looks a little bit like a flat tire. Okay, and you can plug in points, but remember it has to go through these 2 points of intersection that we found. And this one is going to look something like this. That's really this part should be more rounded. Okay, but remember it's just kind of a flat tire. That top part just kind of flattens out. Okay, so once you find your points of intersection, make sure those are accurate on your graph. Okay, now another thing that you're going to be asked to do on this worksheet has to do with the Rose curves. And we know this is a Rose curve because it's got a number times sine or cosine and then a coefficient of theta. Okay, so this one wants to know where the petals begin and end. Well, the petals are always going to begin and end at the pole. And at the pole, you've got to remember that your R value is 0. So we're going to substitute in 0 for R, and then we're going to solve the equation again. Okay, now if I've got 4 times that, if I divide by 4, 0 divided by 4 is still 0, equals sine of 2 theta. Do not divide by that 2 right now. 2 theta is the angle. So what we're going to do is we're going to pretend this is sine of theta. And we're going to ask ourselves, where does sine equal 0? Okay, so we're going to have to think about our unit circle. Sine is y over r. Okay, so I want to know where y is 0 because those are the places where sine is going to equal 0. And that is at 0, at pi, at 2 pi. If I kept going around, it would be 3 pi, and so on. So I can go as far as I need to, as many rotations as I need to. So 2 theta equals 0, or pi, or 2 pi, or 3 pi. Okay, and I can keep going. Okay, but I don't want 2 theta, I want theta. So to get rid of the 2, I just now have to divide. If you've got a number with the angle, you need to wait until after you've done the reference angle before you do the division. Okay, so theta would equal 0, or pi over 2, pi, 3 pi over 2, and if you keep going one more time, 4 pi over 2 would be 2 pi, 5 pi over 2, and keep on going in that same vein. They will start to repeat after a while. Okay, but these are the places where you're going to end up back at the pole. That's where your petals begin and end. Okay, now what is the maximum value of R on your graph? This part you can actually tell just by looking at the equation. So whatever the length of the petal is, that's going to be your max value. So name the values of theta that give the maximum value for R. So if I want R to be 4, I'm going to plug in 4 for the R, and I'm going to solve again. So we're going to divide by 4 first. So we end up with 1 equals sine of 2 theta. Okay, now again, the 2 is with the angle, so I do that at the very end. So I'm going to go ahead and think about where does sine equal 1? And remember, this is y over r has to equal 1. On the unit circle, r is always 1. So I'm looking for where y equals 1. Okay, and that would be at pi over 2. Okay, so I'm going to end up with 2 theta equals pi over 2. Okay, now remember, I could keep rotating. If I rotated one more time around, then I would be at 5 pi over 2, because that's one rotation is 2 pi if you add that on. And we could keep going. We would end up with a 9 pi over 2 and so on. Okay, so now I've got 2 theta. I don't want 2 theta, I want just theta. So I'm going to divide by 2, but since I have fractions this time, it's going to be easier to think of it as multiplying by a half. Dividing by 2, multiplying by half are the same thing. Okay, so I'm going to end up with pi over 4, 5 pi over 4. Okay, and if you look at your pattern, 9 pi over 4. Okay, and we could keep going. 9 pi over 4 is actually in the same place as pi over 4, so it would start to overlap. As soon as it starts to overlap, you don't need to continue any further. Okay, but those are the places where your graph is going to reach the maximum. Okay, now remember what this looks like. Okay, so we can kind of sketch the curve. Okay, so we know the petals begin and end I'm going to put in the maximums, pi over 4 and 4. Okay, 5 pi over 4 and 4. Okay, but if you recall, Rose curves have to have, if it was 4 sine of 2 theta, if this number is even, that tells me that I have to double it. So that's going to give me 4 petals. If it's an odd number, then that's how many petals you have, but the even's double. So I need 4 petals. Right now, I'm only seeing 2. Okay, so the 4th petals would have to be halfway in between, so it's on the other pi over 4s, because they're always symmetric when you're drawing the rose curves. So I can go ahead and put those points in. Now, I'm going to do something else first before I sketch in the leaves, because I want to know where these two graphs intersect. So I want you to pause the video for a minute and find the intersection points for these two curves, polar curves. Okay, remember to find the intersection. We set the two equations equal to each other. So I'm going to have 2 equals 4 times the sine of 2 theta. I need to get rid of the 4, so I'm going to divide both sides by 4. And I get 1/2 equals the sine of 2 theta. Okay, again, the 2 that's with the theta, we're going to wait until after we find our reference angles before we deal with that. So where does sine equal 1/2? And we did this earlier. Sine equals 1/2 at pi over 6 and 5 pi over 6. But that's 2 theta. And I don't want 2 theta, I just want theta. So I would have to divide by 2, which is the same thing as multiplying by 1/2. Okay. So I'll end up with pi over 12 and 5 pi over 12. Okay, so let's put those 2 points on our graph that we just had. So pi over 12 and 5 pi over 12. And I can also, I need to go back and figure out what my R value was. Okay, so if this is my theta, okay, well, R is 2 at all those points, so I actually don't even have to solve. So I would have the point 2 and pi over 12 and 2 and 5 pi over 12. Okay, so let's graph those points on the grid that we had before. Pi over 12, 5 pi over 12. So that kind of tells you how wide your petals should be. And remember, we said this was symmetric. So if I've got points at 2 on the pi over 12s, then that's actually going to happen in every quadrant. Okay. So here's your rose curve. And remember, we were trying to find the point of intersection for this graph and for r equals 2. Well, if you think back, that's one of the very first things we graphed. R equals 2 is a circle that's centered at the origin and has a radius of 2. Okay, so it's just if you go out to the second radius and follow that line, that circle on the polar paper, we actually have 8 points of intersection, and it's all the pi over 12s. The reason we didn't get that by solving is because some of those values would be negative in your table, and we just didn't go through that. But if you'll draw the graphs, then you can figure out where the others are. And remember, rose curves are always symmetric. If you have any questions, be sure you ask when in tutoring or when you come to class.